This is 3.3 General Solutions of Inverse Trig Values. Now remember, when you're looking for arc cosine of 1/2, you're really looking for an angle whose cosine is 1/2. Remember, on a cosine function or any of our trig functions, remember they keep going. So I could just keep going with this one. And you can see that right here at 1/2 or at -60, I have a value of 1/2. And then at 60, I have a value of 1/2. So as my graph keeps going, I could keep having value of 1/2. Let's see, I have another value over here. At 300, I have a value of 1/2. And at 420, I have another value of 1/2. So number one, it asks you to plot those points. And it says, what is the relationship of the first two values? Let's label these because they're going to ask something about some of these other ones in a minute. So this is the first, the second, the third, and the fourth value. So between the first and the second, you notice you've got -60 and 60. So those are symmetrical here. So I'm going to say the relationship is symmetrical about the y-axis. Okay, on number two, it says, what is the difference between the third and the first? So the first and the third, the difference here is going to be 360 degrees. And if you notice, we've got an exact point here. We start here, and then we start here. So it looks like that is going to be the period. Number three says, what is the difference between the fourth and the second? So second and fourth, that should be the same. It still should be 360 degrees. What do you think the difference is going to be between the other values of cosine of 1/2? Will always be? Well, if these are 360 degrees, I think the other ones will also be 360 degrees. And then what significance characteristics of the graph of cosine does this number represent? And we already said it represents the period. Okay, let's move on to the next one, or to number 5. Number 5 says, at what x values do you think the 5th and the 6th dot will be? Well, if we know, if we go from 1 to 4, you get, from 1 to 3, you get 360, and 2 to 4, you get 360, then we can just add. So I think the 5th one is going to be at 660 degrees, and the 6th dot is going to be at 780 degrees. So we're always going to do a period and add 360. If you can find the first two values of x, where cosine is 1/2, then you can find an infinite number of values of x by adding multiples of 360. All right, so this right here is important. If you notice, we keep saying the word 360. The general solutions are, so we started out by talking about general solutions. And on your previous picture, we talked about this right here where we had 60 and -60. Now that's important. Now if you're a memorizer, anytime you have a cosine graph, you can use these as your general solutions. And if you're not a memorizer, I can show you how to use this information. So the first thing that you're going to be given is you're going to be giving cosine of something, and you're going to be given an exact value. So what I would use with this is I would know that cosine is adjacent over hypotenuse. And since we're working with arc cosine, you need to know where arc cosine falls, and that falls on the top. And since it's positive, it's going to be over here. So I would draw my positive values and set them up. So this is adjacent over hypotenuse, and then this is going to be your other side, so this is going to be 1. So you need to find your angle. Of course, this is going to be 30 degrees. So it says find the principal value of arc cosine. That's 30 degrees. So I'm going to jump down here. It says, what is your general solution? Well, my first general solution is going to be 30 degrees plus 360 in. And since we're in degrees, we're using 360. If we were in radians, we would add 2 pi n. Now, you notice that there was another one, okay? In order to find my second part of my angle, it says if the value of the graph is cosine, then the other negative is going to be negative. Now, this is how I would approach this. All students take calculus. My angle was positive. Cosine was positive here. Cosine is also positive here, so it's not going to fall in these two angles. So if cosine is positive down here, then you would draw this triangle down here. Your hypotenuse was 2. Your adjacent was root 3, and this was 1. Now if you go down, then that's going to be a negative. So across from that would be a negative 30. Okay? So you could either, you know the angle is going to be down here, so you could say that this is going to be a negative 30 degrees, or if you wanted to, you could plot it and go all the way around here, and that could be, or 330 degrees. Okay? So I would take either one of those angles. Personally, I like the negative 30 degrees because it's a smaller number to work with. Now I'm going to take either one of those. All right? So we have two general solutions, which you're always going to have. So now when you take your two general solutions, it says to use integer values of n to come up with the first 3 positive values. So now you just take any number in the world and you plug them in here and find the 3 smallest numbers. So I'm going to start here and say, well, can I plug in a 0 and get a positive answer? Can I plug in a 1 and get a positive answer? And then I do the same thing here. So it looks like I can use this one, and I can plug in a 0, and I get 30 degrees. That's one answer. I can also use this one and plug in a 1 and get 390 degrees. That is another answer. If I use my next one, my negative one, I can plug in a 1 and I still get a positive answer. Okay? Those are my first 3 positive answers. Okay, let's look at the next graph. It says, similarly, there are infinite numbers of values of x that satisfy sine of 1/2. So this is arc sine. So remember, sine starts at the middle, increases, and then it continues. Okay? So let's place a dot at 1/2. So my 1/2 is going to fall at 30 now, at 150, at 390, and at 510. Again, I'm going to say this is my first dot, my second dot, third dot, and fourth dot. So every other dot still happens with a difference of 360. This number represents the period again. For both cosine and sine, there are how many values per period? There are 2 per period. So if you start here and then you end, there are 2 dots per period. Your first dot occurs at 30 degrees, which is the principal value. The second occurs at 150, or 100 degrees minus the principal value. Okay, so remember, if you were to do, let's say this is 30 degrees, you say 180 minus that to get it. So this is 150 and 30. Once you have the first 2 values, then you can find the infinite number by adding multiples of 360. Okay, thus the general solutions would be, once you find your first one, which is 30 degrees plus 360 n, again, you can use your all students take calculus. We found the first angle to be positive, which was sine. Sine is also positive here. How do I get a positive angle over here? Well, I just drew it up here. So you have 30 degrees here, or you have 30 degrees here. And in order to get 30 degrees here, you have to subtract to get the 150. And that's how I got it. So this would be 150 plus 360 n. All right. So now let's practice this sine one. Remember, sine has the side, and this is positive and negative, so we're going to draw a side up here. This is opposite over hypotenuse, so this has to be your unknown, so it looks like we're going to be working with 60 degrees. So I start my first general solution automatically. So this is 60 degrees plus 360 n. You're always going to have 2 with sine and cosine. So if I look at my all students take calculus, sine is positive here and here. So if I have a 60 degrees over in this quadrant, how did I get 60 degrees? So it looks like my next one's going to be 120 degrees. So 120 plus 360 n. So to come up with my first 3 positive values, let's use my small one first. So if I say 360 n, I can plug in a 0 to get 60 degrees, and I can plug in a 1 to get 420 degrees. So there's 2 values. If I use my next one, 120 plus 360 n, looks like I can plug in a 0. Now remember, you could plug in negative values to see if you can still get a positive value here. Okay, let's try tangent. So tangent says that they want you to do plot points on 1. So where are we going to find 1? Well, here's one at 135. You've got it at 45. You've got one at 225. Remember, you've still got asymptotes here. Okay, not really worried about those. And remember, this is 1 cycle. Okay. So how many times per cycle do you have a point? And this is only once, so this is going to change things. How far apart are each of your dots? Well, it looks like they're going to be 180 degrees. And remember, every time that you write that it represents your period. If you could find the value of where arc tangent is 1, this is your principal value. It is the easiest to find. Then you can find an infinite number. Remember, this keeps going. And then you can keep finding those by adding 180 degrees. Remember, tangent and cotangent are always change. They're always different. They're always 180 degrees. And if you notice, I said that they only happen at 1 time. You will only have 1 general solution with this, which people really like. So my 1 general solution here is going to be 45 degrees plus 180 n. So tangents are super easy. So let's use tangent here. Remember, tangent falls on the side and it's positive, so it's going to be on top. So let's draw this triangle. This is opposite over adjacent, so this is going to be 2, and that's going to be 60 degrees. So my 1 general solution, A says find the general solution. So x is equal to 60 degrees plus 180. Remember, tangent is 180 n. That is my 1 general solution. For B, it says find your 3 positive values. So all I have to do is plug in numbers into this equation. So what can I plug into here for my first positive values? I'm going to plug in a 0 to get 60 degrees, plug in a 1 to get 240 degrees, and plug in a 2 to get 420. And those are my answers. Now let's do some practice problems. It does say to do this in radians. Okay, so let's look at sine. This is opposite over hypotenuse. And this is negative, so I'm going to build this in the bottom. So my first triangle is going to be built down here, opposite hypotenuse, and this is going to be 1, so this is going to be where my negative falls. So I need to find my angle right here, and it looks like it's going to be negative 60 degrees. So the first thing I'm going to do is set up my first general solution. So x is equal to negative pi over 3 plus 2 pi n. So when I check all students take calculus, my angle is negative. So sine, it can't be here or here. I've already built a triangle here, and I need to build it right here. So my second triangle falls here. Still with the same numbers. I've got 1, I've got root 3, and 2. You can draw the negative angle from here, or you can do positive and build it around this way. I'm going to go ahead and do the angle positive around this way. So that would be x equals 4 pi over 3 plus 2 pi n. And again, there's many general solutions you could do. You could do the negative angle this way as well. So my answers for that would be 4 pi over 3, 5 pi over 3, and 10 pi over 3. Again, if you did the different general solution, it's not going to change my b values. Let's look at tangent. Tangent is opposite over adjacent, and my restriction is on the side, and it's going to be on the bottom. Remember, tangent only has one general solution. So I'm going to build this on the bottom. Opposite is going to be root 3 over adjacent. This is going to be negative, and this is going to be 2. So again, my opposite, or my theta, is going to be 60 degrees. So A is going to be x equals negative pi over 3 plus pi n. Remember, it's 180. So my b values, or my first three positive values, are going to be 2 pi over 3, 5 pi over 3, and 8 pi over 3. Okay, when we're looking at secant, remember secant is hypotenuse over adjacent, and this is opposite of cosine, so we need to look at the top, and this is going to be built on the left side. So hypotenuse is going to be root 2, and adjacent, so it looks like my negative is going to fall here, and this is going to be 1, so I've got a 45-degree angle. So I need to know what gives me this angle. It can't just give me this, so what gives me that? So that's going to be x equals 3 pi over 4 plus 2 pi n. And my second one, if I do all students take calculus, so where is secant negative or where is cosine negative? Can't be here or here. So I've built it here on the second quadrant, and it's going to be in the third quadrant. So I'm going to build my second triangle down here. So I've already done 3 pi over 4, and I can build it as 5 pi over 4. If you would like to, you can go ahead and give me the negative angle as well. So my b values, my positive answers would be 3 pi over 4, 5 pi over 4, and 11 pi over 4. And my last one is opposite over hypotenuse. This is a negative value, so it looks like it's going to be built down in the fourth quadrant. So opposite over hypotenuse is 1 over 2. So it looks like this side is going to be 3. This 1 is going to be negative, so this is going to be a negative 30 degrees. So for A, I'm going to say x equals negative pi over 6 plus 2 pi n. For B, if you think of all students take calculus, sine needs to be negative. So it can't be here or it can't be here. So it looks like the third and fourth quadrant. So my second triangle is built in the third quadrant. And again, you can build it building positive or negative. I'm going to go ahead and build it positive. So that would be 7 pi over 6 plus 2 pi n. My first three positive values would be 7 pi over 6, 11 pi over 6, and 19 pi over 6. All right, bring questions to class.